Hola amigos, welcome back. So now in this video we'll be trying to figure out how to solve inhomogeneous differential equations. And now, how do you know an equation is inhomogeneous? Well, recall that homogeneous equations take the second order ODE form and it's equated to 0. Now notice this isn't 0 anymore, we're dealing with a gx. So because we have a function on the right side, or term or constant, whatever, anything that isn't 0, then we'll be working with inhomogeneous. Okay, so what does the definition part below say? Well, we know on the left hand side that the homogeneous part, when we try to calculate the general solution, we will call this the complementary part. So the complementary solution will be the general solution of the left hand side. And when we get to the right hand side, we're going to get this part in a second. We've got something known as the particular part. Now the particular part, otherwise known as the particular solution when you solve it, i.e. yp for this one and yc for the left side. This kind of equation is sort of a guessing game, okay? We're going to get some sort of expression here, and what we really do, we set this to a function yp, and we set a constant to it. Example, if it was an exponential, it would be yp equals a constant times that function. We differentiate and substitute into this left hand side, and what we do is equate each side and see by matching coefficients. Anyway, enough talking, let's jump straight to it. So the idea is that the general solution always takes the form of the solution of the left hand side and the solution of the right hand side. So let's rub this board and go right to it. Okay, so now that we've spoke a bit too much and understood exactly what the complementary and particular part is, let's do one nice example. Okay, so example 1. Let's try and find the complementary and the particular solution to this one. Suppose we have a second order ODE, a very nice, beautiful, simple one. Minus 12y equal 3e to the power 5x. Okay, now recall that the left hand side is the complementary part, so we're going to be working with the homogeneous part. Okay, so that is the idea. So pretend this part don't exist. So what do we have? So what we have now is y prime minus 4y prime minus 12y equals 0, the homogeneous part. And now we just have to find a characteristic equation again, so it's a quadratic. So we just say m squared minus 4m minus 12 equals 0. Solving this quadratic, what we should get, it's quite easy, the roots here, we should get m minus 6, m plus 2. Minus 12 it can be made by minus 6 times 2 plus positive 2. Minus 4 can be made by minus 6 plus 2. So this is correct. And thus, our roots here is m1 is plus 6, m2 is negative 2. And thus, the complementary part of the solution ycx would be, based on the general formula, is going to be c1 e to the power of minus 2x plus c2 e to the power of plus 6x. I mean, I could have done a 6 and minus 2, but who cares? And constants are here to be solved if we have, boundary values or IVPs. But in this case, this is just a general working out. So this is the complementary part done. Now we're going to do the particular part, the YPT. So what do we do here? Well, let me just rub this board and keep this on the left hand side. I'm going to quickly pause and shift this out. Okay, we're back. So I just delete the expression below and copied it at the top. So now that's the complementary part done. Let's work on the particular part, okay? So how does it work exactly? So remember, we have to start thinking of derivatives for this expression and see what our guesstimate solution would be. So over here, what I'm trying to say, suppose for our particular part, if we're going to differentiate this once, what would we get? Well, we would get a constant times e to the power 5x, and again a constant times e to the power 5x. So our guesstimate solution would be some solution which is a constant times e to the power 5x. And this would be what we think our general solution should be based on this kind of expression. If you had a sine 2x or something, then the solution would be either sine or cos. So this is kind of what we're expecting. I'll show you a table on the next example before we tackle it to get an idea of this. So this is going to be our equation. So now all we do here is differentiate this twice and substitute this into the variables above and match the coefficients. Okay, so let's do this. So differentiating this equation once, drop the 5 down, we're going to get 5a e5x. Next, differentiating this one once again, dropping the 5, we're going to get 25a e5x. And that's it. Now substituting back in here. So what do we get? Okay, so guys, what are we getting here? Well, we're gonna get 25a e 5x minus 4 times 5, which is 20a e 5x minus 12 times a. 12 times this one would give you 12a e 5x, and all of this should equal the right hand side. Of course, everything's in terms of 5ex, so now we're just solving for a here. Matching coefficients of e5x. What do we have? On the left side hand, we've got 25, take away 20 is 5, take away 12 minus 7a. And this should equal the right hand side, which is 3. So therefore, solving this algebraically, so dividing minus 7, we're gonna get 3 over minus 3 over 7. And that's it. This would be how you do it, guys. Now you got a, and all you do is substitute this into here, and then hence our general solution for this part is going to be this plus this, so it would be c1 e minus 2x plus c2 e 6x minus 3 over 7 e 5x. That's it. This will be the first part done. So now I'm going to work on the second part. Okay, guys, and I'll show you the tables for right now. Okay, guys, so here is the undetermined coefficients table. Okay, so this is the table we get when we're trying to deal with the right hand side of the equation for gx. Okay, so looking at the possibilities it can take. So suppose we had a function, the exponential we just did. We can guess our solution to be in this form, which is true. Derivatives of these will be in this form. Now if you had a sine or cos, the reason why we have two forms here, not just one, is because you differentiate sine, it will be the cos. Differentiating cos is going to be sine. So really, and then you'll be having two sets of coefficients to substitute and to link up. So this would be how it should work, okay? Likewise for cos, and same for this one because this is quite trivial now. Now for the nth degree polynomial, this is, for example, if you had an equation, let's say x cubed plus 2x. Okay, so you know your solution is going to be ax to the power 3 plus bx to the power 2 plus cx plus d. I should write plus z, not plus zx. And the reason why I wrote z is there's not 26 combinations. I didn't want to write a1, a2 up to an. I think this is more trivial, more easier to understand, and we kind of like it nice and basic. Okay, so again, this is just for the nth polynomial. If you had a third or fourth, power starts on 4 and you keep going down and sticking coefficients up to the constant parameter. And otherwise x to the power 0. Okay, so now we understand this table, so let's try and jot this in our mind. Let's do another example once again, okay? Okay, so this needs to go. I'm going to stop this video. Okay, we're back again. So once again, you probably notice on the left hand side that we still got the same complementary equation. But we don't care about the complementary this time. We're just going to focus on calculating the particular part, sine 2x. So recall from the table. So if we're dealing with sine 2x and we differentiate, we get a solution in terms of cos and sine. So that means our particular part is going to be some solution in terms of cos 2x plus some solution in terms of sine 2x. Okay, and that's it. Now we just differentiate these terms and smash it back into the equation. So let's do it. Taking the first derivative. So if you're not sure how to differentiate this, click on the annotation that you see on the screen right now. Okay, anyway, as for everybody else, let's go. So differentiating this entire equation, this would be minus 2a sine 2x plus 2b cos 2x. So remember, differentiating sine gives you a positive cos, differentiating cos gives you negative sine. And again, differentiating once more. This part we're going to get minus 4a sine cos 2x minus 4b sine 2x. So this is really easy to screw up, so be careful, yeah? And lastly, substituting all this back into this equation, which is going to be painfully long. We're going to have, well, this into here would just be, so I'm going to call this C and I'm going to call this S, okay? So just to save time. So now what we're going to have minus 4a cos minus 4b sine minus of 4 times all of this, and then swap the signs. We're going to have plus 8a sine minus 8b cos, and then minus this part we're going to have right down here minus 12ac minus 12bs. Oh, yes, yeah, haha. And this would equal the right hand side of this equation, which would be here, which would be equals sine equal s. Yeah, equal s. And now matching coefficients, which is quite easy this part, you'll know straight away. Matching sine with cos. We can see on this cos is obviously nothing, so everything you match here will be nothing. But for the sine, what do we have? Okay, so collecting sine terms, we're gonna have minus 4b plus 8a minus 12b, and this should equal 1 because s is 1. And once again for this part here. What do we have? So yeah, let me see. Okay, so minus 4a minus 8b minus 12a. Okay, and this should equal 0. Now we just solve this algebraically. Okay, so what do we have? So minus 4b, 16b, 8a. So our simultaneous equation here will be, so let me just quickly, so if you're not sure to do simultaneous, again click on the video, click on the screen. So quickly solving this, and yes, this should be it. So I'll just quickly pause then calculate. So now solving this simultaneously, what do we have? Well, let's do this. We could just double this one and then subtract it because it's 0 here. So doubling this one again, you get 16a. So this would be 16a minus 32b. Okay. And then this would be obviously plussing. Now plussing, actually this would be 0 minus 32 minus a to be minus 40b, and this would equal 2. That means b here obviously equals, let me see, that means b equals minus 1 over 20. And doing the same thing for a, you're gonna get a equals 1 over 40. Okay, just substitute back in, you can get a equals 1 over 40. And then thus our particular solution, let me just rub all this out. And we are back at the top line. So back on the top line, we said a was what? A was 1 over 40, good. 1 over 40 cos 2x, and sine was, b was minus 1 over 20 sine 2x. And that's it guys, this is complete 2.